Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Oh, good morning, all. How are you all doing? Okay, we're starting. Now, in last week Saturday, we talked about graphing, right? Is that not? We talked about how to graph. And I explained what graphing is. Graphing is like a technique, right? Used to show the relationship between two or more variables. Is that not? It shows how a variable depends on another variable. Is that not? I would say we have different kind of graph. We have what called the linear graph, right? Linear graph. The general form is what? Yeah, y equals ms plus c, right? Are you following? Are you in the class last week? Wow. We have the linear graph. The general form of all linear graph is y equals ms plus c. When they say linear graph, a linear graph is a graph that has the highest power of what? 1. It's linear because the power is what? 1. For example, if I have y equals 2x plus what? 4. The highest power of x is what? Is 1. So this is the linear equation. The linear what? Equation that can generate a linear graph. So to plot a graph of y against x, when x is known, let's say for instance, we are given the value of x as 0, 1, 2, 3, 4, 5, right? When you plot a graph of y against x, the value of x is given, right? We can determine the value of what? Of y. When x is 0, y is 4. Is that not? When x is what? 1, y is what? 6. Just like that. So when you get the value of x and y, then you plot your graph. When you plot a graph of this equation, your graph must be of this kind. Your graph must be of this kind. The point here must be what? 4. Because we say that all linear graph has what? Y equals to what? ms plus c. Y represents what? Dependent what? Variable, right? Are you there? Dependent what? Variable. S represents what? Independent what? Variable. C represents what? The intercept on the y-axis, right? Is that not? What's that C? Intercept on the y-axis. And the intercept on the y-axis is when x is equal to what? 0. Alright? Then what again? M represents what? Our slope or gradient. Is that not? That represents what? Changing y over changing what? X. Are you following? All of these things you know. You know how to find slope, right? Okay, so we say C is the intercept on the y-axis, meaning any point where this line, we call this line what? Regression line, right? Line of best fit. The straight line that best fit the graph. Any point this line cuts the y-axis is called what? The intercept. Right there. And that occurs when s is what? 0. Is that not? This is the origin, right? This is origin. The value of s is what? 0. So intercept occurs when s is 0. Are you following? Now, y is called dependent because the value of y depends on what? On s. Meaning without s, I can't generate y. The equation has been given. S has been given. If for me to find y, I have to substitute what? X. So x becomes what? The independent. What's a y? Dependent. For all linear equation. Are you following? Even for all quadratic equation. Now, we have the linear graph. We say that when you plot a graph of y against s, a graph like this must be obtained. Y axis, right? This what? The x axis. Are you following? When you find your slope, changing y over what? Changing what? X. I mean, these are changing y. Okay, these are y rather. Our slope here is what? Changing y over what? Changing x. Your answer must be what? Yeah? Must be equal to 2. You know why? You know why? The general form says what? Y equals ms plus c. What's our slope here? M. Abi? When you compare this with this, it means my slope is what? Is 2. What's the intercept? 4. So that means when you get the actual value of x and y, and you plot this graph must meet y when y is what? 4. And when you find the slope of this graph, you must achieve what? You must have what? 2 as your slope. Because the general form is this. Am I communicating? Go back to my video last week. Go and watch my YouTube video to help you. Okay, but let's look at the other form of graph. We have what called the what? The what? Quadratic what? Graph, right? The general form is what? Y equals to what? Ax squared plus bx plus c, right? Are you there? We have what called this is also known as what? The parabolic what? Graph. A parabola is called what? a quadratic what graph. Any graph of this kind, hmm? Or this kind, it can also come this way, or what? This way. There's a topic people will be doing in your second semester mathematics called conic section. Under conics, we have parabola, we have ellipses, we have circle, and we have hyperbola. All parabolic curve must either be of this kind. It's either it's facing up or what? Facing down, or it's facing this way or this way. Right there? But in general knowledge, any graph that has a curve is what? Quadratic graph. Eh? Or a parabolic what? Graph. And the general form is this, right? Then we have what we call the cubic. Cubic is simply y equals as cubed plus what? bs squared plus what? Cs plus what? D. Cubic means the highest power is 3. Are you following? The nature of this graph, I can't capture it now. Then we have what we call the sine graph, the sine and what? And cosine. We have what we call the hyperbolic graph, the hyperbolic graph. Okay? We have what we call the ellipse, ellipses. These are different forms. There are many of them. We have many of them, many of this kind of graph. But physics 107 only captures what? Linear graph. Only linear graph. Oh yeah, please put this down so we can write down some things. My major aim is graph transformation. Okay, let's look at graphing. For those of you who missed last week, Saturday, graphing. And I want to change some of your belief on that graph. Now, I'll be changing them now. We have two ways using graphing. Two methods of graphing. We have by plotting just the points. By plotting the points. Which is also known as by what? By ratio. By what? Ratio. We have what we call by regression. Regression what? Analysis. These are the two ways. When you get the word by plotting, by ratio, the following ratios we actually adopted while plotting the graph. We have 1:1, 1:2, 2:1, 2:2, 3:2, 2:3. Let's say 3:3, 4:3, 3:4. We can have 5:4. We can have 4:5. We can even have 4:4, even 5:5. Now listen. By ratio, we mean some points will fall this way, right? Some points will also forward the other way. Right there in the graph. Let's say for example now, I have a graph like this. And I have some points here, right? On the line. Are you there? Let's say I have a point here, another point here, I have a point here. This graph is called what? 2:1. Meaning 2 points are here. 1 point is here. 2:1 is a perfect graph. If I have 1 point here, 1 point, what is it? 1:1. Perfect graph. If I have 1, 2, 3 here, what is it called? Ratio 1. It's not really good. If your own graph is 3:1, another person's graph is 3:2, there will not be similarity in your slope. Your slope will be different. Are you getting the gist now? So you must have to look for a perfect ratio. Don't allow too many points to cluster on one side of the graph than the what? The other one. Are you getting the gist here? So for this now we have 3:1. It's not really advisable. But if it's the only ratio you can generate, that is the lowest ratio from your graph, just go with it. But most of the time you can even have how many points here? 3 points. This is what? 3:3. 3:3 is also equivalent to what? 1:1. Because 3 can go with 3 to give us what? 1, 1. If 3 points are here, 3 points are here, this is also a perfect graph. Are you getting it now? Sometimes some points will be here, right? Like 4. Let's say like 3 will be here. Maybe only 2 points will enter the line. You can even have a graph like this. Let's say you can even have a graph like this. 1, 2, 3, 4. And here is 5. 5 here. 4 here. And no point is on the line. Is it possible? Have you ever seen that before? No, right? But it's possible. That assignment you are given to plot the graph of t square, is it t square of L against t square? We use what method to solve it? Regression analysis. We now find out that almost all the points, at the one point, right there, 1 point was here on the line. And some other person's graph, no points even enter the line. I think that graph was about 5:4. Yeah, are you following now? So not all the time. But how do we know which of the points to use? That is where this will now come in. But most of the time in the particle or after plotting your graph, so after identifying your points, if you cannot solve with this, just make sure that you have the appropriate what ratio. Don't allow too many points to cluster in one side more than what the other. Are you getting it now? Now, if you can be able to achieve your ratio, a perfect ratio, that straight line drawn is now called what? Line of what? Line of what? Best fit. Line of what? Best fit. It's not just called line of best fit because it's a straight line. It's called line of best because the line cuts across a good what? Ratio. Are you getting the gist here? It's the line that best fits the graph. Not all lines best fit the graph. I can have a point, I can have another graph like this. Let's say a graph like this. Because I have 4 points here, I will not choose this, Abi. Is that not? Then neglect what? The other one. Is that not? This is not line of best fit. Do you know what is line of best fit? How many points is here? 4. How many points are here? 0. Then if you have the 4 ratio 0 graph, you are wrong. So this line you are drawing is not what? Line of what? Best fit. Are you getting the gist now? Good. So just make sure you identify your ratio very well. 1:1, 1:2. What do you notice in their difference? Difference of what? 1, Abi? Is that not? If you have 4 is to 6, is also good. You know why? Can 2 go here? Can 2 go here? What do you have here? 2:3. Are you getting it now? 4:6 is also a perfect graph because when you divide their ratios, you have what? 2 ratios. That means 3:2 is also what? A perfect what? Graph. Are you getting the gist now? I put this down because I'll be solving. We'll be looking at the graph we are solving. So put it down. For those of you who are not here, then we'll look at regression analysis. Now let's look at the second method, which is what? Regression, right? Regression analysis. Regression analysis, please write. Regression analysis is a mathematical approach, either approach or method used in determining the line that best fits the graph. Used in determining the line. I said it's a what? Mathematical what? Method, right? Or approach used in determining the line that best fits the graph. That best fits what? The graph, right there? It is used, right, to find the slope. It is used to find the slope and the intercepts. It is used to find the slope and the intercepts, right there, of a linear relationship between two variables. Of a linear relationship between two or more variables. Without plotting a graph. Without plotting what? A graph. Put this down. The following are the formulas that must be noted. The following are the formulas that must be noted in regression analysis. The first is the general linear equation, which is y equals to mx plus c. That's the first. Okay. The second is the value of our slope. That's what I would say that this y represents what? Dependent variable, right? What's the m here? Slope. What's the s? Independent variable. What's the c? The intercept on the what? Y-axis. And this occurs when s is what? 0, right? Good. So the value of our slope m is equals to n summation of xy minus summation x summation what? Y divided by n summation x squared minus summation x all what? All squared. Okay? For the slope. for n. This m represents this, where n is the number of experiments conducted, either number of data. Sum of xy means what? You must have gotten your xy. Your x is what? Independent, right? What's the y? Dependent. So when you multiply your x by y, that will give you what? Sy. Then you add up all the sy to give you the sum. Are you following? Then x square means what? We square all the value of x to get what? S square. Huh? Sum of s square. Are you there? Okay. Then the value of this c is equals to y bar minus what? M what? S bar. Where y bar is equals to sum of y over n. S bar is equals to sum of x over what? N. Let's put this out. Okay, let's look at one example from your textbook. The table below shows the values of x and y obtained in an experiment. We don't know what x represents, but let us look at it. We are given our x and what? And y, okay? We have x, right? We have y. We have 30. We have 40. We have 50. We have 60. 70 and what? 80. Are you following? Then we have our y, which is 43. We have 45. We have 54. We have 53. We have 56. We have what? 63. Are you there? Okay. Now look at the question. For instance, find the line of regression or line of best fits. Find the line of best fits or line of regression for this experiment by plotting the graph of y against x. Find the line of best fits or line of regression for this experiment by plotting the graph of y against what? X. A graph of y against what? X. From this experiment, find your slope and the intercept. Find your slope and the what? Intercept. Find your slope and the what? Intercept. Okay? Also add this question. Also find the value of y. The value of y when x is equal to 55. Also find the value of y when x is what? 55. The value of y when x is 55. Are you there? From your graph. From your graph. Okay. We are given this, right? And we have to find what first? Line of best fit. Is that not? From the formula I gave us, we are told that y equals to what? Ms, right? Plus c. Where m is what? Sum of what? Sy or sum of what? X. Sum of y over what? N. Sum of what? S squared or sum of x. All what? All squared. Where y equals to what? So where c equals to what? Y bar minus what? Ms bar. Y bar means the mean of y, which is sum of what? Y over what? N. What's the s bar? Mean of x. Sum of x over what? N, right? Now from this value we have here, we need colon for what? We need sy, right? Is that not? We also need what? Also need what? S squared. Are you following? Sy means x times y. Now point for me calculator. What is 30 times 43? Let's start. Multiply this for me. What do you have there? 1290, right? 1290. What is 40 times 45? Sorry, sy. Sorry. 129. Now s squared, 30 squared is what? 900, right? What is to find the sum of what? X. Sum of what? Yeah? Y. Sum of what? Yeah? Sy. And sum of what? S squared. Sum of s. Let's add up everything here. 330. Thank you. What about sum of y? I guess it's 314. Please confirm. Sum of sy is 19,900. Sum of s squared 17,000. 930. When you add up this plus this, that will give us 330. When you add up this, we have this. Add up this, we have this. Add up this, we have this. Please add. Let's confirm what we have. I don't trust this material. Okay, let's check. When you add up this, what do you have? Okay, this answer should be here, right? So this is what? 17,930, right? What about this? 19,900. Thank God we have to correct this, right? If not, we just commit academic suicide. Now, let's go. So what do we do? We have to find what? Line of what? Best fit, right? Good. That means I have to find the value of my what first? My slope. Is that not? Recall that slope is given as what? N summation what? What's the slope? From here now. N summation what? Sy minus summation x summation what? Y, right? Over what? N summation what? S squared minus summation x all what? All squared. So let's go. So what will be our M here? What's our N? 1, 2, 3, 4, 5, 6. We have 6 experiments. Is that not? 1, 2, 3, 4, 5, 6. So we have 6 here. 6 times what's sum of xy? 17930, right? Minus sum of y is what there? 330, right? Times what? Sum of x is 330 now. Is that 330? Times what? 314. So times 314. All divided by what? 6 times what? What's that? X squared? 19900 minus what's the sum of x all squared? Sum of x all squared, meaning the sum of this x, 330, then square it. What is 330 squared? Sum of x all squared is not equals to what? Sum of what? X squared. Are you aware? This is important. This means I have to sum all my x and square it. Are you getting the gist? So what do you have? 108,900. Are you sure? Okay, so our m becomes what? Multiply this for me. 10758 only. 80. Minus multiply 330 by 314. What do you have? 103620. Divided by what there? Multiply this from what do you have? 119400 minus 108900, right? So what's that slope here? Subtract for me this numerator. I'm coming first. What do you have? 3,960 divided by what? Subtract what do you have here? 10,500. Then divide this to what do you have? 0.3771. Okay, what is your question? Okay, this 6 here. We have 6 experiments. 1, 2, 3, 4, 5, 6. So the number of data we use is 6. So the slope there is what? 0.3771. Okay, correct. So let's move down to what the next we're looking for. Well, let's find our C, right? Our intercept. Step C, recall that C equals to what? Y bar minus what? M what? M S bar. What is our Y bar? Sum of Y over N. What's sum of Y there? 314 over what? 6, right? And what do you have there? Give me the value. Divide. 52 point what? 33. What about our S bar? What's our S bar? Sum of X over what? N. That will give us what? What's sum of X there? 330 over what? 6. And what do you have? 55. Okay. 55. Thank you. Therefore, our C becomes what? What's our Y bar? Our Y bar is 52 point what? 33 minus what's our slope there? 0.3771 times what's the S bar? 55, right? So that means our C it becomes what? 52 point what? 33 minus, multiply this for me. What do you have? 24 points. No, I mean this value, yeah? 20 point what? 74, 74435. 35, right? So let's say 444, right? Huh? Okay. So subtract. What do you have here? What's the value of C? 31 point what? 5856. Okay, so you can say C is what? 31 point what? 59, right? Or 59. Yes, 59 is okay. Are we okay? Okay, 31.586. Huh? Is that okay? Where? 0 point. Is there a mistake somewhere? Where? 741. Is what you gave me now. 20.7405. That's all. Okay, let's subtract now. 31 point what? 5895. Okay. Which is the same as what? 31 point what? 59, right? Huh? Okay, I think the same answer, but just that. Just a little differences. I work on them. 31 point what? 59. So this is our value of C. Now, are you done with this page? Right. I want to clean it. I will not need to. Okay, let us look at this. Let's bring up all the parameters we will need. What's our slope? 0 point what? What's our intercept? 59. What's our S bar, comma Y bar? What's S bar? S bar is what? Comma, what's our Y bar? Point what? 33. Just put this down. These are the values we need. That means naturally, if I'm to plot a graph without doing this, a graph of Y against X, your slope must be equal to what? 0.3771. What will your intercept? 31.59. Are you getting it now? So these are ways of finding slope and what? Intercept without plotting graph first. Are you there? But I'll now show us how to convert this into your graph. Converting this into graph. That's the major part you need to learn. So you can know how to do it yourself, okay? Okay, now the next is how we can plot in this to have a perfect graph. Look at this now. Let's see this is my graph, right? Please bring out the graph notes now. Bring it out, your graph notes. This is my graph. What do you have here? Y as right. What do you have here? X as this. Are you following? In your graph, we have different boxes, right? That makes up what? The graph. Is that not? Different boxes in this graph. Okay, this is our graph. This is the nature of your graph. And we have different boxes here. Now, if you look at this, you're plotting a graph of what against what? Y against what? X, Abi? Good. Now, the highest number here is what? 63. What is the lowest number? 43. Are you there? So, to choose a scale on the y-axis, there are some things you have to take note in the graph. One is what? Scale, Abi? For the y-axis, you can use 2 centimeters to represent what? 10 watts. 10 units. Is that not? Is that not? Meaning, on the y-axis, every of these balls represent what? 10. What be here? 20. We do the same thing with me. What be here? 30. What be here? 40. What be here? 50. What be here? 60. What be here? 70. The highest is what? 63, right? I will stop here. Is that not? Huh? Now, the same thing on the x-axis. We are choosing a scale now. 2 centimeters to represent 10 units. So every 2 centimeters, put what? 10, 10. 10, 20, 30, 40, 50, 60, 70. Do that now. Or you come to this side. Come and sit down here. So I can do what she's doing. Come. If you don't know how to plug graph, yeah, come this side. This was my last class. We are here to learn together. Those who can plug graph, who knows how to choose scale, to assist others. Why I use 2 cm? It's because of the nature of your graph. Look at your graph here. This is 2 cm. Are you there? 10, 20, 30, 40, 50, 60, 70. If I use 4 cm, I can't capture all these points. If I use 40, 10, 20, 30, 40, 50, what is here? 60. The highest is what? 63. So the only best scale to use is what? 2 cm. Are you getting it now? So just start from here. Count what? What's the highest here? 63. So start with 70 here. 60. Are you seeing it? 40. This is your graph, right? Are you seeing what I'm doing here? So on the y-axis, the highest number is 63. Okay, that means I'm to start from here. I will start with what? 70, 60, 50, 40, 20, 10. Then I'll now roll what? My horizontal what? Yeah, line. You know what I have to start from here, so I can leave a space here. Sometimes you don't just go. Mistake people always make is that you just take your y-axis and take your x-axis from here. Most of the times your graph can be of this kind. You can cut the y-axis along the what? Negative side. Hope you're aware. Are you aware? So that means it's not really good. You just come to this side and rule your what? Your x-axis. Always count. Get your y first. The least is 43. What's the highest here? 60. So I will start from 70. I will say 70, 60, 50, 40, 30, 20, and what? 10. What's the next one? 0. Then rule your line, leaving a space below. Have you done that? Well, do that for me now, all of you. Now we are done for the y-axis. This is our 0 point, Abi. I think the same scale we also go for what? For x-axis. The least is what here? 30. What the highest here? 80. So let's come here. Here we what? 10, Abi. We have what here? So here is 0. Here is what? 10, 20, 30, 40, 50, 60. Please continue with your own graph. Your graph, I think we capture up to 80, right? Okay, then we have 70 and what? 80. Just like that, We have 70 and we have what? 80. If you have 90, you can also put 90 because the highest is what? 80. You can exceed if you want to exceed. Now, let's start plotting our graph. Listen now. This is the easiest scale to choose. 2 cm to represent what? 10 units. That means each of those O's represent 1 unit. Is that not? How many O's do we have here? 10, Abi. So that means that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that not? 11, 12, 13, 14, down to what? 20. Likewise, the x-axis. Is that not? The same thing. 1, 2, 3, 4, 5, 7, 9, 10. Just like that. Now, can we now locate when x is 30? Y is what? 43. Can we locate that? We are plotting y against what? X. What is our y? 43. What is our x? Oh yeah, look at it now. Y is 43, Abi. Here is 40, right? So that means I will count how many lines after 40? 3 lines. 3 O's, right? So we have 1, 2, 3. Against what? Against what? This is 30, right? So somewhere here. Is that not? Is that not? Have you done that for me? Now watch. Let's go. Have you captured this point? Good. What's the next one? 45 against what? 40. What is 45? Middle, right? Where's that 40? There, right? Is that not? Okay. So do that for me. Have you done that? What's the next one? 54 against what? 50. 54 against what? 50. Where's 54? This, right? Where's that 50? Somewhere here, right? Somewhere here. 54 against 50. What's the next one? 53 against what? 60. Where's 53? Here, right? Against 60. Where's that 60? Somewhere here, right? Okay. What do we have? 41. Where is it? 53, right? Against 60 has been done. 56 against what? 70. 56 against 70. This is my 70. Around somewhere here, right? What again? What again? 63 against what? 80. 63 against 80 is there. Against what? 80. Somewhere here, right? Are you done with that? Are you done capturing this point? Now look at this now. If you look at the nature of your graph, please pay attention and listen. The points are scattered, Abi. The points are not straight. Are you getting it now? You will not be confused. Which of these points will I choose to give me what? Line of what? Best fit. Is that not? If you're in a particle or you can easily use what? By ratio. Right? Just look for the ratio, either 1 ratio 2, 2 ratio 3. Is that not? Is that not? Or 3 ratio what? 3. Because the total point there is 6 points. Are you following? Now, but let me show you what you will do. What is our x bar and y bar? Our x is what? I will locate these points on this graph. Are you getting the gist? This point is what? This point is what? S is what here? 55, Abi? When S is 55, somewhere here, right? Is that not? Uh-huh. What is our y bar? 52.33, right? I will then go up. I guess somewhere here, right? Huh? Yeah, right? Somewhere here, right? Oh yeah, let's go. Let's take it. Just circle this for me because this is the only point that is not the main point from the graph. Just circle it. 52. 52.3. Just when you go to 52, between 52 and 53, halfway. Do you understand? Let's say, for example, now watch. This what? 51, right? This what? 52, right? This what? 53, right? Between 52 and 53, just halfway. Half what? Halfway. Is that clear? Have you done that for me? Locate it to what? 55. Have you done that? Now watch. 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 Pay attention. What's the next point here? 31 point what? 5. This is almost what? 31 point what? 6. Abi? Is that not? Your C is called what? Your intercept. Where is intercept located? On the y-axis. So I will locate what point there? 31.6 on the y-axis. This is 30, Abi? This is 30, right? This is what? 31. Halfway is what? 31.6. Have you done that for me? Locate your 31.6 on the y-axis. Here we have 30 now. The next line after 30 is what? 31. Then the next is what? 32. Then between 31 and what? 32. Halfway. Have you done that? So what do you do there? Just put your plus here. Or you circle here also. Have you done that? Now look at this. In some case, I will need to find another point. The major point we need now is this our C and what? S bar and what? Y bar. The major points. Just forget about other points on the graph. Are you following? The major point we need now is our C and what? S bar and what? Y bar. Leave other points on the graph. So I will now connect this with this using a straight line. But sometimes I can decide to find another third point that will give me one line of what best fit. Let me show you something. Look at this. What we see is the general form of linear graph. Y equals to what? Ms plus C. Are you there? This graph has an equation. Let's find the equation of this graph. The equation is what? Y equals to what? What's the M? What's the M? Take your 0.3771x. Abi? Plus what? What's the C there? 31 point what? 59. This is the general form of this equation. You know we say y equals to ms plus c. What's our c? The intercept on the y-axis. Is that not? What's our m? The slope. What's our y? Dependent variable, right? What's our s there? Independent variable. I can then decide. I can do what? Decide to find another point on this graph. Maybe I can choose when s is what? When s is 30. When s is 30, let's take. What's our y? Let's go. Y equals to what? 0.3771 times what? 30 plus 31 point what? 59. Abi? What's our y? Multiply 0.3771 by 30. What do you have? 11 point what? 313. Is it just like this? Okay, plus what? 30 what? 1.59. Please add up what you have here. 62 point what? Be fast. Be fast. 42.903. So that means that when x is what? 30. What's our y? Y is what? 42.903, right? Is that clear? I can also locate these 2 points on the graph. If that point, this point on the graph will be in straight line with this and this. Can we find it on the graph? What's our x here? 30. Are you there? What's our y? 42.9. Meaning between 42 and what? 43, Abi? What is 40? This 41, Abi? This what, yeah? 42. 42 point what? 9 should be somewhere here, right? As against what? As against what there? 30, Abi? Where's that 30 there? Huh? Against 30. Yeah, right? Somewhere here. Is that not? Also do one for me. Circle this point. This is not a perfect graph. My graph is this is just a rough test. So use your own graph and connect these points with these points and this point together. Look at this. From your number, from your graph, you notice that just connect for me. This is the rough thing. That's what the whole thing is scattered. Are you getting it now? Link your words. What's our C there? 31.6. Abi around here. What's our S bar and Y bar? 55 point what? 50 S bar is what? Let me do this again. 55. What's our Y bar? 55 is here, right? Someone here, right? Let's someone here. Okay, the middle, right? What again? The new point is what? 42. I get it somewhere here, right? Right? 42 and what? And 30. This is what I want to generate here. Now, from your graph now, here we have our C, right? Here we have what? The new value, right? The new value, which is when X is what? 30, Y is what? 42. Here we have what? Our S bar and what? Y bar. So connect this point using a straight line. Take a straight line here. Connect them together. These 3 points. 1, 2, 3. Have you done that? Is it a straight line graph? Okay. A graph like this, right? A straight line graph. Cutting the intercept. Abi? Cutting the new point we calculated. Also cutting what? The S bar and what? Y bar. The S bar and Y bar. Are you there? Are you following? It must cut these 3 points. Then other point will fall outside. Abi? Is that not? Is that not? Now, when you draw your straight line, are there any points apart from these 3 points that fall on the line? No other point fall on the line. Let me see your graph. You're not doing your line. Let me see your own. Perfect. Look at this graph now we have here. This graph we have here. This is the what? The intercept. This is the new point we calculated, right? This is what? The Y bar and S bar. Perfect line. What do you notice here? How many points falls on this side? How many points are here? 2 points. How many points are here? 4. So what graph is this? 2 ratio what? 4. Which is the same as what? 1:2. Are you getting the gist here? So this is the perfect graph. 4 points. When you draw this line, you notice that we have a point here and what? Another point here. Are you there? Then we have 1, 2, 3, and what? How many points? 4. Is that not? 2 points falls there, meaning 2 is to what? 4. Which is same as what? 1 is to what? 2. So this is the perfect graph. Now you have seen that not all the time that all the lines, all the points will what? Will be on what? On the line. Are you getting the gist here? Okay. This is 100% accurate together. So that means that the line that best fits the graph is simply what? This. Then when you now find your slope, let's find slope from this graph. How do you find slope? Change the what? Change the what? X. Abi? Now to find slope, the mistake people always make in slope finding is that they look for their slope from those points. Is that not? We are all victims of this in secondary school, even me. You don't look for slope from the points. You look for your slope from what? The line. The what? The line. Are you there? This line we call is called what? Line of best fit. Also called what? The regression line. Regression what? Line. So I will determine my slope from here. Just get a line. This line Y as is. Are you there? Then connect to what? To any point here. Let me see your graph. Draw a vertical line from any point here. Okay? Draw a vertical line anywhere on the point, on the line. Draw a vertical line. Okay? Anywhere on the what? On the line. Then connect it with any point on this line here. Now, from what shape do we call this? What shape is this? A rectangle, right? To form what? A rectangle. Just generate a rectangle. That's what I mean. So draw vertical and what? Horizontal. Have you done that? Listen. Actually, this third point is not really necessary. Last, we only use 2 points, Abi. We use your intercept and what? Mean of S bar and what? Y bar. What you can get your intercept and get your mean of S bar and what? Y bar. Just connect both of them together. That is all. That's the major thing, because any other line here must have to give us something related to what? To your Y and what and X. It's a relationship. So what connects them is what? Your intercept and what? And your S bar and what? Y bar. So just connect all the points together. So when you connect them, you find out that some points will either meet a little, while some will be on the line. Are you following now? So you must not necessarily find when S is over 30. Do you get the gist? Okay. Now when you find your slope, listen, take any point, right, from the slope. Look for your change in Y and what, yeah? Change in X. Our slope is giving us what? Change in Y over what? Change in X. What are change in Y? Y2 minus what? Y1 over what? S2 minus what? S1. Now from your graph, determine your own slope.
You can choose
any point. Your slope, but like I say, you can choose any point. It must not be here and here. It can be here and here. It can be this way. Are you getting what I'm saying? It can be this way. But any value, any point you are choosing on this line must give you equal what? Slope. Because it's a straight line. Is it not? It's a straight line that forms the slope. So it has, every point must have equal slope on the graph. Have you done your slope? Yeah, just write it here. Yeah. Solve it here. Oh yeah, look at it, look up. Let's choose this line here. Locate the value of Y here for me. From here, this point here. What is the value of Y here? Use your ruler and trace down to your Y axis. What's your Y? This is your Y2. Your Y2 is here. This is what? Y2. This is what? Y1. Hope you are aware. Then on your X axis, this is what? Your S2. What will this point, this line intersects here is what? Is your what? S1. Do that for me. Your Y2 is here. Take it to this Y axis. Get the value for me. What do you have there? It will differ from, you guys will have different values. Hope you are aware. Use your own value for me. I want to get something. What do you have as a Y2? No, this. Okay, so let's look at this. Give me your own value again. Your value, what do you have here? What's the Y2? 62 minus, what's the Y1? 40. What's the S2? 80, right? What's the S1? 22. So when you subtract this, what do you have? 22 minus, what do you have here? 58. So what do you have when you divide these two? Divide 22 by 58. 0.379, which is what? About 0.318. Abi? What's our slope from this, from our regression calculation? What this is our M? 0.377 what? 1 Abi? Which is also what? 0.38. Are you seeing it now? That's your slope from your calculation must be in line with your slope from what? The regression.